Part A of question number 4 wants you to find the average acceleration of train A over the interval where time is over the interval of 2 to 8 minutes, pretty much. So basically, since the function is a velocity, finding the average acceleration is the same as finding the average rate of change between minutes 2 and 8. And the way you could do that is pretty simple. All you need to do is take the slope between between 2 minutes and 8 minutes. So to do that, you would go negative 120 minus 100 all over 8 minus 2, because this is the slope between points 2 when t is equal to 2 and t is equal to 8. So that ends up being negative 220 over 3, or over 6, my bad. And that simplifies to negative 110 over 3, which is the answer. And you put that in the units that they give you. Since acceleration is the slope of meters per minute, so it's basically if y is equal to va of t, then x is equal to t, and y over x is equal to the slope. So it's meters over minutes divided by minutes, which is number 4, shown here. In order to get full credit, you need to show two things. First of all, you need to show that you know that negative 100 is between the velocity found at time equals 8 and the velocity found at time equals 5. And the second thing is you have to prove using the IVT and write a conclusion that there's a point t where VA of t is equal to negative 100 between minutes 5 and 8, pretty much. And that's what the question wants you to prove. Anyways, so how you would go about doing this is, first of all, know that between minutes 5 and 8, the velocity changes from 40 to negative 120, where negative 100 is in between those two numbers. So you could put this, basically. And second of all, you need to know that they tell you that the train's velocity is differentiable, which means it's continuous, because in order for something to be differentiable, it also has to be continuous. So, using the intermediate value theorem, which states that if a function is continuous and there's 2 points where the y values of those 2 points are, say, like, I don't know, 4 and 8, there's some point between the two x coordinates that give those two y coordinates where there's a number that gives a value in between those two values. Yeah, so the final thing you need to do is write a conclusion. So you say by IVT, there's a time where 5 is less than t, which is less than 8, where VA of t is equal to negative 100. He asks, given the information about the train shown here, to first write an integral that gives the position of train A in meters from the station at time t equals 12. And second, use a trapezoidal sum with 3 subintervals indicated by the table to approximate the position of the train at time t equals 12. So you can get 3 possible points for this problem. The first one is to show the integral that gives the position of train A. Given knowing that t equals 2, the total distance traveled from the station is 300, which is s of 2. And also that an integral of the velocity will find the total change in difference between 2 points in time. So how you would write this out is you would say s of t is equal to the distance function. You could say s of 2, because you know that's 300, plus the integral from time t equals 2 to time t equals 12 of the velocity is the total distance. And that can simplify to 300 plus the same integral, because you know that s of 2 is 300. So the way that you get the other 2 points for part C is, first of all, you have to show a trapezoidal sum, because it asks for you to solve a trapezoidal sum. You need to show how you do that. And the second part is you need to show the answer, which is down here. So how you would do a trapezoidal sum with 3 subintervals between 2 and 12 would be to find the width between the 3 subintervals that you can see, which is right here, between 2 and 5, between 5 and 8, between 8 and 12. You find the widths basically for these trapezoids, and then you find the average height, because that's how you find the area of a trapezoid. You times the width by the average height. Well, yeah, either that or the other way around, where you times the height by the average width, which is more common. Anyways, so you add up the 2 intervals, the 2 y intervals between 2 and 5, and find the average, and then times it by the width. And you do the same thing for this part right here, for this part right here. And then you add 300 to it, because you're trying to find the time not between 2 and 12. You're not trying to find the distance traveled between there, but the total difference traveled since 0 minutes. And so you add all this up. This ends up being negative 450. This ends up being 300, obviously, which means that it would go negative 150 meters to the left, or pretty much, yeah, to the left of the station, which is going west instead of east. So you would say the position of train A at 12 minutes is about 150 meters west of the station. Part D introduces a new train, train B, that travels north instead of east from the station. The equation for the velocity of this train is given here as negative 5t squared plus 60t plus 25. And the distance at 2 seconds is also given right here. At t equals 2, tb is 400 meters north of the station. And then the question wants you to find the rate of change at which the distance between train A and train B changes. That's basically the hypotenuse of this right triangle that they make around the station. So this is a related rates problem. All the stuff we know so far about the distances of train A and train B and their velocities at certain points. So yeah, I'm going to write the related rates equation. So you know this is the this is basically hypotenuse theorem. So it's x squared plus y squared equals, let's say, z squared, where z is the hypotenuse and x and y are like the horizontal distance and the vertical distance. So this is train B and this is train A. You want to find the rate at which they're changing, which is dz over dt. So we'll take the derivative of this equation, and you get 2x times dx over dt plus 2y times dy over dt equal to 2z plus times y times dz over dt. Right? So of these we know, of the following so far, we know dx over dt, which is 100 at 2. We know x, which is 300 at 2. We know y, which is 400 at 2. We do not know dy over dt yet. That's the velocity of train B at 2. And we do not know what z is yet, and we're solving for dz of dt. So the first thing we can solve for is z. We know that they make a right triangle together, like this. A goes along the bottom, and at time equals 2, it's 300. And this is the right angle. And then the other train, train B, goes up, and at time equals 2, it's 400. So this is a right triangle, and it's just a simple 3, 4, 5 triangle. So the answer for Z would be 500. Put that up here. Right? The next bit you want to solve for is the velocity of train B at time equals 2. Then you put that all together and solve for dz over dt, because you know all the other values. So we know that the equation is negative 5t squared plus 60t plus 25. That time is 2, so let's just plug that in. You end up getting negative 20 plus 120 plus 25, which simplifies out to 125. And that is the velocity at 2 of train B, which is dy over dt. So let's put that all together. Let's erase this bit right here. Alright, so when you put all the values that we found into the equation, you end up getting this right here. These are the x derivative, the velocity and the distance and the velocity for y, and the distance between the 2 points at time equals t for z. So straight off the bat, if you don't have a calculator, which you shouldn't for this problem, you could simplify this a bit. So you notice everything's a multiple of 100 here. You could divide by 100, and you could divide by 2 as well, because there should be a 2 here. Because there's a 2 on every multiple, you can divide by 2 and just get nothing. So let's divide by 2, let's divide by 100. We end up getting 300 plus, let's see, that's 500, because this is 125. And this is equal to 5 dz over dt. You get dz over dt equals 800 divided by 5, which simplifies to 160. And don't forget to put units, say 160 meters per minute. Squeezing that in there. But if you have space, you should try and write it better.